Crystal packing in lattices. Crystal structure refers to the unique arrangement of atoms or molecules in a crystalline liquid or solid. A crystal structure is three-dimensional in shape. The arrangement or pattern of atoms in a crystal is repeated at each lattice point. The crystal looks the same when viewed from any one of the lattice points. The points can be thought of in such a way that they form identical tiny boxes that are referred to as unit cells. A unit cell contains one or more atoms. The lengths of the edges of a unit cell and the angles between them are known as lattice parameters. Crystal structures can be classified on the basis of their lattice systems. There are 7 lattice systems. The least asymmetrical system is the triclinic system. Turquoise is an example of the triclinic lattice. The next system is the monoclinic system, and sulfur is an example of a monoclinic crystal. The orthorhombic is another system, and epsomite is an example of it, whereas dolomite is an example of the rhombohedral system. Zircon is an example of the tetragonal lattice system. Next is the hexagonal lattice system. Beryl is an example of this. The last and most symmetrical lattice system is the cubic system. Sphalerite or crystalline zinc sulfide is an example of this type of system. In a crystal, layers of atoms are packed in a particular way. One type of packing is the hexagonal close packing or HCP. The layers are stacked in such a way that each alternating layer is identical. For this reason, the sequence of layers is described as AB, AB, AB. Another type of closely packed structure is the cubic close packing or CCP. The layers are stacked in such a way that every third layer is identical. Therefore, the sequence of layers is described as ABC, ABC. The CCP structure is identical to the face-centered cube and is sometimes also known as FCP. The face-centered cube contains 8 atoms at the 8 corners of the cube and 6 atoms in the faces of the cubes. There are 2 types of holes that exist between the layers of a closed packed structure. The octahedral hole is formed between 3 atoms in a closed packed layer and 3 atoms in another closed packed layer just above or below it. The space at the center of these layers is the octahedral hole. The second hole is the tetrahedral hole. It is formed between 3 atoms in a closed packed layer and a single atom in a closed packed layer just above or below the first layer. While the octahedral holes in sodium chloride are occupied, the tetrahedral holes are vacant. Snowflakes are made up of ice crystals, and no 2 snowflakes are identical. Nature has a hand in the creation of these complex and beautiful crystal structures.